Hey, what's up, guys? John here again. So today let's take a look at this LeetCode problem here. Number 1520, maximum number of non-overlapping substrings. So this is one of this week's weekly contest problem. It's a medium problem, but I'm gonna give it my own upvote. Yeah, I kind of like it. So let's take a look. So you're given like a string. Uh, uh, consists of lowercase letters, and you need to find the maximum number of non-empty substrings that meets the following conditions. So first is the among all those substrings, there can't be any overlapping. Second, a substring that contains a certain character C must also contain all occurrences of C. Basically, if a if a substring contains letter B, for example, so all the B's has to be in this substrings. Basically, you cannot have two substrings have the same letters, right? So for example, here, for example, this this string here, right? The candidate string of this big string is the candidate substring is, of course, this the first one is for everything, right? And then uh, second one is this one, and the fourth one is EF, and the EF and CCC, right? And same thing for this. For this one, the candidates it's like it's A, B, and A, B, B, C, C, and it also asks us if there are like multiple solutions with the same number of substrings. Let's say if there are like three, for example, for this example two here, this this uh, this combination is also like three has three uh, length of substrings. But since this one, the total length of this one is greater than this one, that's why we have to pick this one. Okay. So, at the beginning, it seems like this problem has a lot of conditions and a lot of constraints. So how can we uh, work towards the solution, right? So let's forget about all these conditions for now. Let's assuming we already have all those kind of substrings, okay? And let's say we already have those kind of substrings, then how can we come up with the final result, right? That's the first thing we need to figure out. Assuming we already have all the valid substrings here, right? And then the way we can come up with to the final result is by using a greedy method, a greedy algorithm, right? Basically, for among all those like valid substrings, we sort by the length, right? When we sort by the length, we try to fill, and then we'll be picking the smallest substring first, and then we'll put it into our output array here. And once we have a new one, uh, what do we need to check is we have to check if the current one, if the current substring has any overlap with the substring we already put it into the output, right? For example, this one here. So let me expand this. For example, this example one here. Once we sort it by the length of this substring candidates, right? So the first two will be put into our final result is E and F, right? Okay. And then once we have E and F, the next one we will be popping from the sorted list is this EF here, right? It's EF. But since we need every time when we have a new substring, we need to check if this substring has any overlapping with any of the existing ones, right? We already added into the output, and by checking that, it's basically there's overlapping with both E and F, right? That's why we skip this one. We don't take this one, and and then the next one is it's CCC, right? So that's why the second one is CC, and the third one is the next one is ADEF ADD, and this is obviously this also have like overlap within this range, and the last one is this one, right? Basically, that's how we that's how can we once we have the candidates, that's how we can use this greedy idea to to approach to the final solution. So basically that's the first step, first thing we need to understand, and then the rest will be how can we calculate this substring, right? The candidate substring. That in order to calculate all the candidates here, as you can see, when we check if it has any overlap, what we need is not the actual string here, but we need the index, right? Basically, when we calculate the substrings, we'll be saving the start and end index for each substring, right? And how can we do that, right? Okay, so the way we're doing it is first we'll be storing for each of the letters here appears in the S here. First we'll be storing the start the start and the end index for each letter. For example, we have A D E F A D D A C C C, right? So for example, the A, right? For A, we have a starting point is 0, right? We have 0, and then the end point is 1, 0, 1, 2, 3, 4, 5, 6, 7. So it's 7, right? So the way we're doing this, basically we loop through the index. We loop through the string here, and every time when we see A here, we're gonna use a dictionary or hash map to store this starting and end point. Basically, the first time when we see this A here, we're gonna initialize this both the start and end with the same index, because in the case if there's only one letters here, right? That's the start and end are start index and end index are the same. And then if this if the but and if the letter has already been seen before, we only update the second the end index, right? And then for example here in the D we have a 1 and 1 2 3 4 5 6. It's 1 6, right? And the E is 2 2 2, right? F is 3 2 3, right? And then C, right? And then C is uh, 8 9 10. It's 8 to 10. Oh, right. So once we have those indexes, right? So and then can we assuming this A from A to A is one of the valid substring? No, right? Since okay, so basically the reason we are getting getting the range for each letter is that's our basic start and end, right? Because each substring has to contain all the letters for a specific character, right? That's why in order for to get this A substring, at least the length has to be from 0 to 7. That's how we can make sure the substring will include all the A's, right? This substring. And but in order to make the substring truly a valid substring, what we have to try to expand these things, right? By looping through everything, all the characters within this range, right? As you can see it here, because for this problem, there's nothing here. But let's say, for example, let's say there's another f here. Okay, let's say there's another f here, and the f is sorry, so the f is gonna be 7, 8, 9, 10. So instead of three, did I just my God, okay, I just accidentally remove everything I just drew on the screen here. Okay, okay, sorry. So I'll 0 to 7, right? And then the F, right? D, E, and F. So in this case, the F is from 3 to 7, 8, 9 to 10, right? So basically, once we have this like the baseline for A, right? For this index A, the next thing we need to do is we will we'll loop through everything, all the characters within this range, and basically we'll check if any character, since we already built this range index for each letter, right? So we're gonna check if any the new range within this like range from A to A is outside of this 0 to 7, right? If that's the case, it means that okay, we also need to include a bit more. We have more characters, right? Which means we have to go also check all the letters uh, out in that extra range other than this 0 to 7. For example, this thing. So because for D is within 0 and 7, right? So that we don't need to do anything. E, same thing. But once it comes to F, right? So F is okay. So the starting point is within the 0 and 7, which is fine. But look at 10. The 10 is outside of 7, right? So which means uh, once we finish processing the 0 to 7s, we also need to check uh, 8 to 10, right? Until there's no more range to be processed, right? So basically that's how we calculate the substring. So basically for each of the index, each of the start and end for each letters, index for each letters, we're gonna try to expand it until there's no more new range to be processed. Then we will be getting our new our substrings, and then we'll be okay, and then we will try to sort this. Yeah, and then we'll sort this candidates by the length. All right. Hmm. Yeah. Okay, so let's try to code these things up. Okay. Okay, and cool. So to start with this coding, first we need to create the range index, right, for each of the letter, right? Mm, we're gonna have a index range, right? So index range, letter range. Oh, I'll call it letter range. Okay. Mm, default dictionary. Since we're going to store save two elements, right? Two elements start and end. I'm gonna make it a list here. And the next one is just simply looping through the string here, enumerate as, right? And so I'm gonna do a little bit trick here. Basically, if the character, right? If the character is not in the letter range, right? I I do a letter range dot c dot extend, right? I'm gonna extend this thing with the start and end in with I and I, right? In case there's only one occurrence for this letter, that's why we so the first time we saw these letters, we initialized the start and end index with the same, right? Else, right? If we have seen this letter before, we just need to update the end index because we are looping through from the left to right. Okay, and 1, right, equals to I. Okay, so after this for loop, we'll be having a hash table for each letters appears in this string with its a start and end index. Okay, and the next one will be try to mm, expand the range for each letter, right? For each letter. Mm. So uh, so for key, I'm gonna have like a key and the reason I'm using the key here is the now once we start expanding this range of this substring here, it's not so basically this substring is not only for this letter A or B or C because it could include for anything, right? So that's why instead of using this like a letter variables here, I'm just using the key here, right? So the key is the key in letter range. Okay, so for each of the key, we have a start and end, right? A start and end uh, in the letter range key, right? And to expand this array here, the substring, I'm gonna use a queue here, stack or stack, whatever it is. It doesn't really matter. So I'm gonna use a stack here, and the starting point is the start and end. Okay, and then I'm gonna do a while loop, right? While stack is not empty, right? And mm, mm, current start, okay, and current end is equal to the stack pop, right? And with this a current start and end, we're gonna do a for loop here, right? Basically for I in range current start to the current end. Since it's a inclusive, we're gonna do a +1 here, right? And hmm. And so this is the current start and end, right? And then mm, yeah, so for each of the letter in this range, we're gonna try to compare that range within the initial start and end, right? to check if it's within this range or not. Okay, so we're gonna have a new start and new end. Okay, and the value for those is a ladder range is a current ladder. Current ladder is the mm, SI, right? That's the index. Basically, that's the current index of the ladder. That's why, and with this SI, we're getting the current ladder, and from there we'll get the current ladders and the start and end index, and then we check, right, if the new S is smaller than the start. Okay, if it's smaller than start, then we know, okay, we have a new there's a new range we need to check later on, right? That's why we're gonna do a stack dot append. We're gonna append this new range to the to the stack so that it can be processed again, right? So this new start range is gonna be as the starting is the new s, right? And how about the end? The end is the start minus one, right? Because let's say if this as a if if this start is like 3 to 7 and we have a 0 here, right? We have the new s is 0, so the range we need to add is from 0 to 2 because 3 we already has already been processed. That's why we need to do a new s to this 3 minus 1, right? Okay. And then once we have a new start, we also need to gonna update our start to the new s, right? Because in the end, we'll be pushing this updated start and end back to this ladder range so that we'll have a valid substring range, right? And okay, same thing for the end range, right? Basically, if the new end is greater than the current end, right? And then same thing, we're gonna do a append and to the end plus one, right? To the new end. That's the new a new range we need to check for the other side. And also don't forget to also update the end with a newer end here, right? So basically we'll be keep processing this stack here, right? And but so for 3 and 7, so for the first time, right? For the first time, the start and end is always the same, right? It's always the same because start and end are the same letter as the key here, right? Let's say for example this is A, the start and end will definitely have the same one as A. That's how we get the start and end, right? So basically the when we have this I from current for the start and end, it's the new S and the new E will be the same as the start and end, but it doesn't really matter. We'll just simply skip that because we only update it and when this one is smaller or bigger. So when they are the same, we also skip, right? Okay. And so once there's nothing left in the stack, we know that okay, there's no more new range we need to process, right? And now we can push this updated start and end back to this hash map, right? So that later on we can use that to get our final result, right? And ladder range k equals to what? The updated start and end, right? Since we're keep updating the start and end, we can simply use the same, okay? And okay, so okay. Okay, cool. So, and once we have that, now we have after this for loop, we have all the valid list. Sorry, the valid substring stores in this dictionary, right? Now we just need to sort them by the length, right? I'm gonna have a sorted range, okay, by the length. gonna be sorted, right? So the the candidates are the are the ones in the value in the dictionary with the values, right? And then I'm gonna sort it by the length, right? So since we're storing the start and end index, right? That's why for the key I'm gonna use a lambda, right? Lambda and x equals to x1 minus x0, right? So basically I'm using the end minus the start to be the sorting key, right? That's how this one the sorted range will give us the shortest substring, right? And then now we just need to use a greedy method to output to this uh, final result, right? So I'm gonna have an answer equals to this one here, right? And then uh, okay, so the answer is a string here, right? But since I also need to check the overlap, right? If there's any overlap between the ones we already outputted, and to check that I need the start and end index. That's why I need another list here, right? Uh, mm, Scene ranges. Okay, uh, gonna be a list here. So for start and end, right? Mm, in sorted ranges. Okay, and for this sorted and ranges, first we need to check if the current start end has any uh, overlapping with any of the ranges we currently have seen so far, right? We have seen so far, right? How can we check that? Basically, we do a if we can use any, right? Basically, if any of them is true, right? If there's any of them has an overlapping range, we do a continue, right? Else else we do this. Else we first we add ranges, right? Dot add append uh, start and end, right? And then that's for the scene range, and for the answers, same thing. We do append, but in this case we need the actual string here, right? So it's going to be start and end plus one, right? Because this is a close, we need to include this end position, and then we just simply return the answer. So now, how can we check, right? How can we check if this thing has a has a overlapping? So to check the overlapping with a range with a new range, uh, let me draw two things here. Let's say the start one and end one. Okay, that's a start one and end one, and then we have another start two and end two. Okay, so how to check if this two range has overlapping? So basically, you know, this S2 can and the E2 can be moved from here and until here, right? That's so basically we're gonna only two conditions, right? S2 is, is equal greater than E1 and and uh, E2 is equal greater than S1. So with these two end conditions, we can know there's like a range. There's a overlapping between those two ranges, right? Basically, this S2 has to be before this end one, right? If it's like moving out of if it's like greater, oh, did I, oh, I think I did it wrong. Uh, S2, sorry. Hmm, smaller. smaller, sorry. So this S2 have to be on the left side of this E1, right? And and this E2 uh, has to be on the right side of this S1, right? Because if the S2 moves to the right of the first one's end, then we know there won't be any overlapping. Same thing for the S for the this E2 here. The E2 has to be on the right side of S1, right? So cool. So S1, E1, S2, E2, S1. Okay, cool. So and okay, so now we have this for mm, for S1, right? And E1, right? In scene ranges. Okay. Any for each S1 and E1 in the ranges, if any of them has this like basically if the okay, I'll call it S1. Mm, fine. So if the end is greater or equal than the S1 and the E1 is also greater equal than the start, right? And then we continue. Then we continue. Otherwise, we just do this, right? And in the end, we simply return the answer here. Okay, so I think that's pretty much it is. Let's try to run it. Hmm? Oh, sorry. Since we're getting the string here, we have to use a colon here. Okay, so this one accepted. Let's try to submit it. Cool. So it passed. Uh, yeah. So how about the time and space complexity for this problem, right? So let's take a look. The first one is the time complexity. Obviously, is the n here, right? So the first for loop here, that's the n. And then mm, how about here, right? Another for loop with ladders here, right? So what's the range for this ladder, right? Because it tells you it has to be it's limited to all the lower ladders here, right? So the ladder range at most is 26, right? For the from 0 to 25, right? It's 26 ladders, and for each of the ladders to 26, and yeah, since this is like a constant, right? And it doesn't really matter what we're doing in here, right? 26 and for 26 for each of the range we'll be doing like we'll be doing another while loop here check, right? So something like 26 times uh, 26, right? But still a constant here, still a constant, right? And yeah, so and because in the end we're also still having we're still dealing with like ladder ranges here, right? And to sort these ranges here, it will still be a constant here, right? So because there are only 26 at most 26 elements here, so it's going to be 26 times to sort 26 uh, basically n log n, right? N log 26 is still constant here. Mm. And here it's same thing, right? Because the sorted range is also 26. And yeah, so here it's also 26. Since it's always bounded to 26 letters, so the total time complexity, we can think it treat it as O(n) here, right? Because the n is pretty big. It ends from it's 10 to the power of 5, and all the rest are all they are all bounded to the 26. Mm, okay, and for the space complexity, right? We're defining like this one letter range, which is O26, right? Since at the most there are 26 letters in it, and also here will also be mm, let's see here. Yeah, right. So even though right, so even though the range of the S is super big, but when it comes down to the letters, we'll be having at most 26 substrings, right? In this letter range. So that's why we're gonna have like 26 uh, element in here. Same thing for the answer. We will be having at most 26, and then seeing also 26, basically, and then it's a constant. So the space complexity is gonna be a O1, and the time complexity is O(n), space is O1. Hmm. Okay, cool. I think that's pretty much it is for this problem. And yeah, this is like I would say it's like a almost hard problem because not only it needs you to come up with this greedy idea to come up to get the final answer, but more importantly is how can you get the valid substrings, right? By first getting the start and end range for each of the letters, and then here you have to come up come up with a way of try to expand, making sure the substring includes everything that's inside this substring, all the letters inside this substring, right? And then once you have the once you have the valid substrings, you just need to sort it by the length, and then by using a greedy method to put these substrings into the answers one by one. Uh, okay, cool. Thank you so much for watching the videos, guys, and stay tuned. And I'll be seeing you guys soon. Bye bye.